PH on this corner, and then we had POH on this corner. I'm giving you this, but I want you to find this. You can choose to go that way, or you want to go that way. Either way, same thing. Okay? Going from H plus to pH in this direction, you just take the negative log of your H plus and your pH. Going from OH to H, going in this direction, I can just take my H plus times my OH minus, I forgot the other bracket, that equals KW, which is 1 times 10 to the negative 14th power. So this thing works in either direction because I'm just going to plug in the H plus to find OH, or I can plug in the OH minus to find the H plus. So given the OH minus concentration, I can plug it in here to find H plus, take the negative log of my H plus, and then you find the pH. Or I have the OH minus. I can take the negative log of my OH minus, and that will give me POH. The POH, so the pH plus POH will add to equal 14. So again, this can kind of go in either direction. I can then find the POH, I can then subtract it from 14 to find the pH. There's 2 steps you could have gone on that second problem. Okay? Number 3 and 4, kind of the same thing. Which way are you going? H plus to OH minus. I'm here. I can just go straight down this path. However, you could also go 3 ways, but why?
Oh, so for the problem, would you use that same exact equation on OH minus?
Yeah, like here I gave you the H plus. You can plug in a number there. This number doesn't change. I can just divide and find OH minus. Okay. So again, this one works either direction as well, depending on which way you're going. So then, number 1, we went this way, which was your exponent, 10 to the negative pH. And then the same thing going this way, 10 to the negative POH gives you the OH minus. Okay? So all 4 of those equations, or 5 of those equations, they're on your equation sheet, so we're kind of going to practice those before the exam. That's what that first section was. Okay? Yes?
When will we get our final review set? The essay, is it gonna be again like last time where it's like short answer problem? Can it be that easy again? That's the only thing I've ever done that's easy.
No, actually.
We all got it.
You should do that same exact question again. Oh yeah. I'm convinced you for it.
Okay.
That's something that I could not do.
Next section. Next section, these kinds of problems like 5, 6, and 7. These are strong acid, strong base, weak acid, weak base, dissociation, and even some titration. Number 5 is just finding the molarity of a solution and then finding pH. First of all, is this an acid or a base? It's a base. Okay. I have grams, I have liters, I can find molarity. How do you find molarity? Moles over liters, which means you have to take my 10 grams of KOH. I'd have to divide by the molar mass of KOH. 57. Find moles. Then I can divide that by 1 liter, which hey is the same thing. There's your concentration of your OH minus. Hey! Find pH. A log, all that kind of stuff. So this is just taking the equations that are in that first part, just with a little extra stuff at the front. 6 is just a standard strong acid, strong base titration. What is the equation for titration?
MAVA over CA equals MBV over CB. I did that this morning.
So did I.
I've never seen that.
We wrote it down once and never used it again.
For those who are absent, it was in the video, but we talked about it in class. because we talked about this during that AP testing week. Those who were in class that day, we didn't talk about this in class. There was a video for people who were absent. This was also on the lab, but we did the titrations anyway. If my coefficients, in this case, are both 1, deuces, get out of here. Those coefficients don't matter. Thursday? So, MAVA, this is the same thing as like M1V1 equals M2V2. Except for instead of diluting one solution, I now have an acidic solution and a basic solution. The moles, molarity times volume, is the same in a titration at the end point when the pH is 7. So, if I have the molarity of my acid, which is 3.5 molar, the volume of my acid is 17 milliliters. The molarity of my base is unknown. I don't know what it is, but I do know my volume as 11.7. You can use algebra to solve for the molarity. No algebra? Fine,
I got 5.0.
So the sine of theta equals radical 3 over 2. You'd rather do geometry?
What is that?
You're inventing math, I swear to goodness.
We're doing that in
I
trigger.
barely understand the intro we're doing right now. I don't know.
If I can't do this in trig, I can't do it.
Mr. G.
I don't know why we're trying to.
On the note card, I'm writing that whole thing.
Mr.
Yeah.
If I can't do this in trig, I probably can't do it in chemistry. So don't combine the two.
Yeah. Our friends.
Oh. Guys, what if we all? Are you
I'm
friends?
taking physics.
Now,
It'll be fun.
number 7 was probably going to be the hardest question on the quiz.
Okay, when you're
Because it involves a molarity, a titration, MAVA over CA equals MBVB over CB. But it also includes a weak acid dissociation.
Oh my god. I don't. How do you do
That's
that?
an ice problem. That's
An ice problem?
Vinegar. If you write a simple dissociation for vinegar, I'm going to abbreviate as HAC instead of writing out the acetic acid. It is a weak acid. It only partially dissociates into H plus whatever the conjugate base would be, which is the acetate polyatomic ion C2H3O2 with the -1. Okay. A strong acid, like number 6, hydrochloric acid, 3.5 molar means 3.5 molar of H plus. Acetic acid only dissociates at a very low percentage. So this is 7.5 molar, is not the same as the concentration of the H plus. Yes.
If you didn't know that was acid, how would you look at that?
So give you the Ka value. You don't need the Ka values for a strong acid because like HCl is like 1,000. So who cares? If it's really small, that means it breaks down at a really low rate. So my initial concentration, this is the I, is 7.5 molar. These are both 0 because it hasn't been made yet, it hasn't been associated. The change, I'm losing some unknown X value. These are going to be gaining some X value. So then you have 7.5 minus X, and then it says X and X. The Ka or KEQ expression is X times X, bless you, divided by the reactance, which is 7.5 minus X.
And then you exit out the X.
I gave you the Ka value in the problem, 1.8 times 10 to the -5. Now, option 1, you could solve this using your quadratic formula into the equation solver on your calculator and you get X. But since it's a weak acid and it dissociates small, X is going to be very small. You think subtracting that from 7 is going to be a big difference? No. So you could make the assumption that I can remove that little extra x. Then I can solve for x. What is the first mathematical process?
Well, you would multiply the.
I have to multiply by 7.5 with those numbers.
I got 1.35 times.
It should say first grade. Oh, there was a couple that were like, PA!
Yeah, I did
No.
before school.
While we
Oh,
were
it's
in
big. And second and first grade. Right? Times 7.5.
I don't even know what that is, but they're
Big what?
Then I take the square root.
I got
So
0.01.
x comes up to be 0.0116. Molar concentration.
Let's go with 2.
Why not?
Get that little before I get mine.
0.012, right?
Okay.
Yeah.
So once you solve for x, this is the concentration of x, which is the same as my H plus concentration. If I have asked for what is the pH of vinegar, I can take the negative laws of this, and you can find the pH. Okay? I didn't ask for it to go, but now this number is the concentration of H plus, which means I can take this number and plug it in as the molarity of my acid. So 0.0116 times my volume, which is 50 milliliters, divided by my coefficient. What's the coefficient of my acid?
2.
2. This one is not 1. The molarity of my base is 0.5 molar. I don't know the volume, and my coefficient of my base is just 1. And again, a little bit of algebra, and you can solve for volume. So 0.0116 times 50 divided by 2, and then divided by 0.5 gives me a volume of 0.58 milliliters. This is why we did that titration lab. We didn't titrate with vinegar, because you're looking at like 1 milliliter or less, and it would be really annoying. Yeah. C is the coefficient. It is the balanced coefficient from the chemical equation. There's a 1 here, there's a 2 there. So those are the coefficients that I need to plug in.
Okay, but like, where do you get Z? Oh.
My Z's, I put a little line across it, or across the middle of it, because we know my handwriting.
See, I can't too, it's just.
Are we doing rock, paper, scissors? Okay. So this problem on the quiz would have been like 6 or 8 points. Because you would have had to do the dissociation to find x, and I would love to see your work. Then you got to do the titration part. So it's got 2 parts to it. Sorry. Number 8.
I don't know.
Oxidation numbers. This came from like Tuesday. We're talking about redox. First of all, what is the name of this compound?
I mean.
Okay. The popping that you're hearing, I did a little demonstration this morning. I was playing around really. And the extra that I could not get out onto the paper towels, I just poured down the sink. The substance, when it's wet, is harmless and doesn't do anything. But once it dries out, any touch will make it pop and explode.
In the sink?
So it's in the sink, probably sticking to the pipe, and every now and then it'll dry off and it's sitting on the pipe. So there's some little pieces still floating around in there that I haven't cleaned out. Yeah. Yeah. More of it. A little bit versus a lot. They're all one now. They all pop first period. So, potassium dichromate, actually. Cr2O7 is the polyatomic ion of dichromate. I'm not going to ask you to name compounds on the test. I just like to review stuff from August because I think it's fun. Don't judge. Now, I have 2 potassiums, I have 2 chromiums, and I have 7 oxygens. Their oxidation number should add up to equal what?
0.
0. Okay. What can I plug in? component.
The potassium and the oxygen.
Potassium is in column 1A. It always makes a positive 1, which is why when we name these compounds, they don't have Roman numerals. Libby, what's the other one?
-2 for oxygen.
Oxygen has the highest electronegativity of these three elements. I can plug in -2 as oxygen. And then we can solve. So positive 2 plus 2 chromiums minus 14 equals 0. Combine like terms. So 2 chromium minus 12 equals 0. Add 12 to both sides, divide by 2. Chromium, in this case, is a positive 6. Now, the question says, what are the oxidation numbers for all the elements? Well, we already did these. Oxygen is -2, potassium is positive 1, and then you just found chromium is positive 6. So in essence, you will find all three, but only one is usually the culprit that's changing. In this case, it's chromium. Okay? Number 2, or B, or whatever this is, NO2 to the -1. This is a polyatomic ion, that is nitrite, in case you're curious. So I have 1 nitrogen plus 2 oxygens. They need to add up to equal what? Yeah, because I have an ion charge. That is my total charge of those oxidation numbers. Both of these numbers are non-metals. I can assume this is -3, this is -2, and go, but you may not get it right. Who has a higher electronegativity?
Oxygen.
So plug in oxygen first. So oxygen is -2. So N plus, let's go, I don't like to do writing it again. 2 times -2 is a -4 equals -1. I want to add 4 to both sides. -1 plus 4 is positive 3. You want to be the last one or no?
Yeah.
So IF5, I have 1 iodine plus 5 fluorines. They need to add up to equal 0. Hey, what shape is this?
No, we're not doing that.
No.
Is that gonna be on the test? Please, oh my God.
Molly
Mr.
doesn't
Heeren?
understand it, none of us understand it.
I
No,
didn't
Molly
even know
didn't
this
like
when
it.
we were learning.
I didn't hear that.
Molly doesn't like
Square
it.
pyramid.
House.
Square pyramidal. Right, you're right.
It looked like a house.
Did you say house?
I will
Said house.
That's very good.
Final
I
exam.
don't even think I asked you that one.
Then you're going to guess on.
Wait, seriously, what is industrializer here? What is
We
this?
have to do it again. You know what? Was this just a class thing or did we have to do it?
Yes. I'm still going to work out problems. Okay, so.
It's like
Ladies and the few gentlemen who are to be quiet, so it's just ladies. No, it's 5. There's 5. Who has a greater electronegativity?
Fluorine.
Fluorine.
I don't know.
What is fluorine's charge? What's 5 times -1? Add 5 to both sides. Iodine makes a positive 5. Yay. Okay. The last problem, number 9 on the quiz. You could have your option to choose to solve this one of 2 ways. I didn't care which one you wanted to do. Both of the ways were on your homework. Equation sheet, that's the equation sheet, that's the equation sheet. Homework. So, the homework from, last yesterday. Oxidation numbers, we had redox. This is like the first method, which is really easy, by the way. This is the half reaction method. Both of them get you the same answers, just 2 different ways of doing it. So I'm going to do this problem both ways. You can kind of take a pick, okay? The first method is kind of how you would do it like back in last semester, just balancing equations and looking at the charges of how it changed. First, balance the equation.
One of the NA,
Which one?
both.
Yeah, both. I got 2 chlorates, I need 2 chlorates there, which means I got 2 sodiums over there to match those. That's it. Now, oxidation numbers. What's the oxidation number of sodium on the left-hand side? 0. Why is it 0? It is an element, it is a pure substance by itself. In the compound, I have 2 ions here. I have the copper ion and the chlorate ion. The oxidation numbers, you could find them oxygen, chlorine, and copper individually. Or, in this problem, it's a little bit easier because chlorate stays the same. It does not break apart, which means whatever the oxidation numbers of chlorate are the same on the other side. So you could either A, ignore them completely because they're spectators, or its charge from the polyatomic ion sheet is just a -1. Okay? So now copper, if you looked at Heeren's law and that number at the end, copper ends up making a charge of a +2. On the other side, sodium makes a +1 because it's in column 1A. What's the oxidation number of copper? 0, because it's by itself. Then all you have to look at now is my 3 substances. Sodium, copper, and then in theory, chlorate. Sodium is a 0 on the left, it is a +1 on the right. Did it go up or down? That's an oxidation. Or an anode. Okay. Copper is a +2 on the left, it is a 0 on the right. It went down, that's the reduction. Or cathode. Okay? Chlorate stayed at the -1, which is in essence just the spectator, and that's all we really need to worry about with these two. This is the first option, just finding the oxidation numbers and just looking at who changed. Okay? Let's do the same problem again with half reaction. Okay? I'll do it up here.
Can I take a picture of that?
Sure, I'm gonna do it up here. Half reaction. Sodium started as an element. It's ending as an ion. There's 1 sodium on both sides, but I have a charge. How do I balance the charge? See?
On the side of like the product with the NA+, you put negative, just like what you can see.
I just need to add an electron. So +1 charge plus an electron, they cancel to 0. Is this an oxidation or a reduction? Oxidation for 2 reasons. 1, it goes up, and 2, oil rig, oxidation is losing. I'm losing an electron. Ta-da. Copper. Copper is starting as an ion, but it's ending as an element. There's 1 copper on both sides, but I got 2 positive charges. What do I need to balance?
You have a 2E-.
I have 2 electrons on this side because 2 negatives, 2 positives are 0. Is that a reduction? Because it goes down and I'm gaining electrons. It's the same definition, just a different way of looking at it. Add them up. But I can't yet. 2 electrons with 1 electron.
You have to multiply the top.
Multiply the top by 2. Now, you can do it now or you can do it later, but 2 electrons there, I will have 2 electrons there. Anything that's the same on both sides, you can just cross them off. 2 sodiums plus 1 copper ion with 2 sodium ions plus 1 copper. Gee, doesn't that look familiar? Oh, I missed my 2. It's the same balancing coefficients. My ion charge is just the compound. The spectator doesn't matter. It's the same answer to the same problem using a different method. Correct. Chemistry is all about doing it again, but a different way. Adding on 1 more little extra level of content. Doing doing it using oxidation numbers, using half reactions, you get the same thing. Some people like this method, some people like this method. Take your pick. Okay? On the homework though, I gave you individual sections. I wanted you to do a couple like this, but then a couple like that. You do know? Half reaction. On the homework, this third section, number 1, 2, or 3, all of them are half reactions. Which one would you do? Third one? Number 3, okay? Half reaction. Mercury started as a positive 2 and ending as an element. Is this an oxidation or a reduction?
Mercury's a reduction.
Mercury's a reduction because it's going down in number. So I'm starting with my Hg positive 2. I'm ending at Hg. Positive 2 charge, which means I have to add 2 electrons to cancel, which gives me my charge of 0 on both sides. Which means my oxidation is going to be iodine. I'm starting off with I minus, going to I2 as a solid. Ooh, yeah.
The solid is not equal to 1.
No, that's only for equilibrium. This is not equilibrium. So, I have 2 iodines with 1. Oh crap, I gotta multiply by 2. But this gives me 2 negatives, which means on the other side, to balance those 2 negatives, I need to add 2 electrons. If you go to add them, hey, look at this. I already have 2 electrons on both sides. Yippee. Okay? Just put everything together. I have 2 I minus plus Hg positive 2 going to I2 plus Hg. Basically this is mercury plus iodine. You can combine these together to make the chemical compound of mercury 2 iodide. It's the same substance, it's just broken up into individual ions. Half reactions, looking at 1 half at a time. Hi, how's it going? It's Friday the 13th, which is why she wore that sweater. Lies. You know you did that on purpose.
Is it 13?
I don't know. Is it
May 13th. Okay. Of course, she's wearing a Freddy Krueger shirt, even though that's Nightmare on Elm Street.
Oh, yeah.
It's still just kind of awesome.
Mr. Jason.
Yelling at me? Alright, so that's all the stuff that was the quiz. You had acids, bases, you had some titration, weak acid dissociation.